A very good morning to our lecturer, Dr. Cheng and fellow friends. My name is Cindy Hao. Today, we Group 8 would like to present about the Smart Kettle Monitoring System. Now, I would like to present the background study. In this research, we demonstrate the Smart Kettle Monitoring System technology. We recommend installing the wireless sensor collar on the kettle to collect the health of ecology of the kettle. This helps farmers to monitor cattle from outside of the farm and helps farmers know about the physical condition of the cattle and the state of the cattle received in the event. In addition, facility can be mechanically controlled according to present health parameters and deviation, can be reported through SMS notification service and provide convenience to users. The system will collect the health state of the cow, analysis the health states and daily behavior of cow. It helps farmer to determine in time which cow has healthy problem and need to isolate for future treatment to reduce the risk of the infection to other cattle. This can also be the first time to send a treatment staff to future check and healthy of the cattle and treat them.
Hi, my name is Li Yingfeng. The first problem statement encountered is the sign of diseases and injuries are hard to detect immediately as there are too many cattle. Farmers might overlook the sick cattle. It may lead to death or the disease spread among the cattle. Next, farmer cannot monitor the health information of cattle on real-time basis. It wastes a lot of time, energy and manpower without the help of technology. When there are anomalies in the health information, the farmer cannot take action immediately. The objective of this project is to monitor livestock health in real time, enabling farmers to quickly treat animals and prevent the spread of illness or disease. IoT Collar will help to collect the real-time data and store into database. Data of cattle is managed in the cloud platform. Next objective is to gather and analyze historical data to identify trends in cattle health or to track the spread of illness. All the information is uploaded to the cloud to be visualized. Farmer can monitor the graph and chart to make better decisions. This is the architecture diagram proposed in our solution.
Good morning, sir. I'm Chong Jin. Now I would like to present the literature review and the future work part. For the first review, the author proposed the monitoring method of movement of cow using cloud-based system. The author used IoT and wireless sensor network technologies to detect the cattle movement. It also solved the problem of having to measure the body weight, temperature, and heart rate of the cattle. For the next review, the author proposed IoT-based monitoring system. This system can monitor the health of dairy cows. This system has been tested in the real life and has proved it can work effectively to monitor the health of the cow. For the next review, which is the author proposed precision dairy monitoring technology system to monitor the cow health, time for insemination, and the birthing process. All the data will be collected via smart collar and determined by central cloud-based system. The farmer can check the abnormal cow data and information in the base station. Now I would like to present the future work. For our project, we hope to collect and store more information into DynamoDB in order to improve the accuracy on the analysis part. Next, we hope to add some algorithms that could detect symptoms of other disease, so the vet can cure the abnormal cattle easily. And lastly, we hope to add GPS function into our system in order to help the farmer to monitor the current location of each of the cattle. Therefore, the farmer can minimize the loss of the cattle in the farm.
I'm Cham Jaing, and I will be presenting the relevant cloud technologies in solving the problem. 3 different providers will be listed for each service, which includes Amazon, Azure, and Google. First, for NoSQL database, Amazon provides DynamoDB, Azure provides Azure Cosmos DB, and Google provides Google Firestore. For relational database like SQL, Amazon has Amazon RDS, Azure has Azure SQL Database, and Google has Google Cloud SQL. Next, for notification service, Amazon provides Amazon SNS, Azure provides the same service with combination of Azure Service Bus and Notification Hubs, while Google provides a service with Google Cloud Pub Sub and Firebase Cloud Messaging. For API, Amazon has Amazon API Gateway, Azure has API Management, and Google with Cloud API Gateway. Furthermore, for serverless compute, Amazon provides Lambda, Azure provides Azure Functions, and Google provides Google Cloud Functions.
Hi, it's me again. Now, I would like to say another 2 platform, which is IoT platform. For the Amazon, it provides the service Amazon IoT Core. For the Azure, it provides the Azure IoT Hub. For the Google, it provides the Google Cloud IoT Core. Next, the analysis platform. For the Amazon provides the 3 services, which is Amazon S3, Amazon QuickSight, Amazon Redshift. For the Azure, also provide the 3 services, which is Azure SQL Data Warehouse, Azure Data Factory, Microsoft Power Platform. For the Google, only have a Google BigQuery. Now I would like to talk the connection from caller connect to DynamoDB. First, set up DynamoDB service. Create the sensor data table, fill in the partition key and sort key, then finish create DynamoDB. Second, set up IoT core service. Create the things which is device, fill in the detail and create the device IoT. Create IoT SDK device. In this project, we using Visual Studio Code tools to doing our code. And for the language is JavaScript. This is our code. This is testing for success set up and send message from device to IoT core. This is DynamoDB data when it success store the data inside. This is the alarm signal received from the Lambda.
Hi, I'm Chong Jin. Now I would like to continue the Lambda and the SNS service part. This is the part that we need to set up for SNS service. We need to create SNS topic, subscription, and the desired email. For the Lambda service, we are using Node.js as our programming language. This Lambda will be triggered by IoT core, and this is the code that we implement in this Lambda. It will detect the abnormal kettle and send an email which is abnormal kettle info by using SNS service and store the abnormal kettle data into RDS database. After that, the Lambda will also send back a message to IoT core to notify whether the kettle is normal or abnormal.
I'm Cham Jain, and I will be explaining for the steps between API gateway to RDS. First, a new database is created in RDS. After filling in all details and click Create Database, it will be shown at the database page of RDS. Next, go to VPC Security Group and add a new rule. At MySQL Workbench, enter the endpoint as hostname and enter username and password. All MySQL queries can now be made. For API Gateway, first, the REST API is built. The API name is filled and created. Next, create resource interactions by filling in the resource name. Then, create a method for resource which post is used in this project. Select Lambda function as integration type. After that, deploy API. User can use Postman to post the message in the body. Lambda function which is connected is triggered and the message is stored into RDS. Status 200 will be returned after success.
Now I'm going to present the QuickSight service. First, we have to create a new analysis by adding a new dataset, selecting from a data source. Then we can prepare the data. We select data field we want to visualize and also edit the data field. After finish editing, we can visualize the data in this visualize section. We can customize the graph. We can choose the data field and type of visual. We can also add filters to filter the data. Here are some examples of graph generated. This graph shows the health condition of all abnormal cattle. This is the count of abnormal cattle detected by timestamp. This graph shows the abnormal records for cattle C0008. This is the number of cattle sold by month. This pie chart shows the number of cattle by breed. This table shows the feedback from web. That's all for my part. That's all for our group's presentation. Thank you.